Hello engineers, welcome to another video on low-level design. In this video, we'll look at a simple pattern called the facade pattern. I hope you're ready. Let's get started. So as usual, we'll start with the intent. So provide a unified interface to a set of interfaces in a subsystem. Facade defines a higher level interface that makes the subsystem easier to use, right? Very simple to understand. So there is a facade system which will talk to the other subsystems, and the client only has to deal with the facade system, and the client is not aware of the subsystems. So the implementation details of the subsystems are hidden from the client, and facade brings out a beautiful interface which combines all these interfaces so that it is easier to use for the client, right? So that's the idea behind the facade pattern. So hide all the complexity that is within the subsystems and then use the facade pattern to solve a complex problem that involves more than one system, right? So that's the whole idea behind the facade pattern. So let's see some example use cases. So the first example is payment processors. You must have used payment processors before if you paid for anything online these days. So when you fill your details like credit card details or net banking details and you say make payment now, there's a bunch of things going on. So one system is talking to your bank to check if you have sufficient balance. Another system is actually checking for fraud. And if there is any failure or success, you will be notified on screen or via email or SMS that there has been some failure. So this is a notification system, and there can be multiple such systems like that which are working together to solve a payment process, right? But we don't need to know all that as clients. All we are saying is make payment, right? And internally everything is managed, and this is a very good example of a facade pattern. So as a client, I am not having to deal with each subsystem individually. I am just having to deal with one facade which will take care of my entire payment process, right? So that is a beautiful example of a facade pattern. Next example is GraphQL. This is an excellent example for facade because GraphQL provides a single interface for all the APIs. So it gives the schema for interacting with the data models, and as a client, I am flexible to choose which APIs to call. This is especially useful when we want to deal with nested resources, right? I don't have to call one API, get the resource, use that ID to call the next API to get those resources. I can choose to combine resources and make one API call to get that. So the GraphQL interface reduces the complexity of using REST APIs, right? It also solves the problem of overfetching and underfetching. And that's why this is a very good example of a facade pattern, right? Another example could be any type of apps that involve multiple systems. So for example, the weather app, right? So if you're looking at a weather app, you're getting temperature, humidity, precipitation, forecast for the next few days. So these are multiple systems working together to give the output, but you are seeing everything on screen with just one click, right? So this is again another example of a facade pattern. So wherever you're seeing multiple systems working together, but you don't have to deal with each of those systems individually, then you are using a facade pattern in some way or the other, right? So these are some of the examples. Now let's take a look at the implementation details. So let's go to UML diagrams now. So this is the class diagram implementation of the facade pattern. Very simple to use. So what does it do? Let's say we have three subsystems and we have a facade system, right? So the facade system will compose all the subsystems required for the facade to work, right? So there's a composition relationship between each subsystem and the facade. So all these subsystems are inside facade as a private variable or a protected variable. And when we want to do operation, the facade can choose which subsystem to call upon and do which type of operation to perform a certain task, right? Very simple implementation. It's just a simple usage of composition of multiple systems, right? Let's see the sequence. So the client wants to do some operation that involves multiple subsystems, but the client will call upon the operation only on the facade class. Then the facade class internally calls upon subsystem 1, subsystem 2, subsystem 3 and use their responses to deal with the response for the client, right? As you can see, client is only calling one operation to facade and facade is returning to the client. The heavy lifting is done by the facade class, and this is why the client is unaware of all these complex operations, but the client is expecting the output and the output is given by the facade, right? So the responsibility of doing the heavy lifting is with the facade, and individual subsystems can do their own functionality and they are not aware of facade. So for this system, client is making the call and not facade, because the term facade is not there composed anywhere in the subsystem. So these subsystems are unaware of the facade. So they act independently of each other, and the facade is acting like an orchestrator between them to perform some complex operation, right? So this is the sequence diagram of the facade pattern. So let's take a look at an example. Like always, let's build a payment processor system. Okay. So let's say we have a bunch of services, a bank service, a fraud detector service, a notification service, and a logger service. Okay. And all of these are required to process a payment. And all of them are independent classes, right? So what do? We provide a payment facade which composes of all these services. So in the private space of this facade class, we have 4 different services, right? And we are exposing only one method called process payment. So the client will call on process payment. So the facade will take in the operation request and perform all these operations. First, it will go to the bank service to check if there are enough funds. And if there are enough funds, we move on to the next step to check if there is a fraud involved here some way, right? If fraud is not involved, then we move to the next step, which is transfer money from account A to account B. And once that is done, we want to notify to the customer that payment is success, and we want to log to some database or some log file that the transaction is completed with the transaction details, right? So there are like 4 or 5 steps involved, but only one method call is making all this happen by using the facade pattern, right? So if there is any failure in any of the systems, facade can return the request as failed to the client, right? So the client has to deal with only the facade, payment facade, instead of going to the bank service ones or the fraud detector ones and so on, right? So it is simplifying the implementation on the client side to a great extent, and that is the power of this pattern, right? So let's see all this in code now. So I'm in VS Code now, and we have the facade folder which with facade.cpp, right? So let's build the individual pieces first. First, we have the bank service, which is having 2 methods, verify funds and transfer money, right? Very simple class, simplified for our easier understanding. And then we have the fraud detector, which is exposing one method is fraudulent. It will return true or false. And then we have the notification service, which has one method, notify customer, which will take in a customer email and sends out a message, right? Simple service. And then we have a logger class, which will take care of logging a transaction to the console. Okay, very simple. 4 individual systems doing their own responsibilities and not dependent on each other, right? Now we have the facade class, which will have in the private space all the 4 services: bank service, fraud detector, notification, transaction, right? And it exposes only one method called process payment, which will take in whatever is required to process the payment, the from account, to account, the amount, and the email, right? So what does this do? It will call upon each service individually now. Step 1, verify funds. So bank service dot verify funds will call the bank service method of verify funds using this private object. And if there is any failure, we will use the notification service to send out an email saying payment failed, insufficient funds, and we will return false from here, right? So if verify funds is returning false, we go into the if statement and return false. Similarly, if fraud detector is also returning false, then we return to the customer saying there is some fraud detected, right? Again, returning false. And the third step is to actually transfer the money, and if there is any issue with transferring the money, we return false, right? So these are multiple checkpoints for the process payment method. If everything else is passed, so if all these steps are passed, we will simply log the transaction and we will notify to the customer that payment is processed successfully, and then we return true from here. So in every other step, we return false. Finally, we will return true. So this indicates that the process is successful, right? So this way, the facade pattern uses multiple services within itself and processes a payment which involves multiple systems and multiple steps, right? So let's see the implementation. So we have the from account, to account, the amount, and email, and we are just creating a payment facade class object. and then calling upon process payment. So we will pass in whatever is required to process the payment, and we will just wait for success or failure. If it is a success, payment is success, we will do something else for that. And if it's a failure, we will say payment failure, right? So very simple implementation of the facade pattern. So let's run this code and see. So it is going through the steps. First, verifying funds, checking for fraud, transferring the amount, logging transaction, and notifying customer, right? So there are 4 subsystems involved here, and it is going through each step and verifying the payment, right? So in this way, we can use the facade pattern to simplify the complex operation and give only one common interface for the client to make things easier. So that's all about the code implementation of the facade pattern. Now let's look at some trade-offs. So these are some of the trade-offs. First is great simplicity, because client will have to only deal with the facade class instead of dealing with multiple subsystems. And it also provides great decoupling for the client, because again, client does not have to deal with multiple subsystems, and this provides the simplicity and decoupling, right? So there is reduced dependency with each other. And in terms of weaknesses, as developers, we need to deal with additional layer of code. So the facade class is an additional layer in our design. So all the subsystems need to be composed, and they need to be organized in such a way and so that the facade works, right? So that is one layer to deal with. And because client is only dealing with one facade, so if there's any issue with the facade, the client is stuck. There is no way that the client can communicate with the internal subsystems, because we have hidden that using this layer, right? So this is one of the weaknesses. So if the facade is not implemented well, we are failing the entire operation, right? So that is something to keep in mind. Okay, so those are some of the trade-offs. So that's it for this video, guys. We have covered the intent, the example use cases, the UML diagrams, the code, and also the trade-offs. So if you have any questions, definitely put them in the comment below. Thank you so much for watching. Do leave a like if you found this helpful. Do subscribe to the channel if you haven't done already. Thank you so much for watching. I will see you in the next one. Cheers.